Every day, over 100,000 chapatis roll off production lines in a single modern factory, feeding thousands of people. But have you ever wondered how a simple ball of dough transforms into India's most beloved flatbread at such an incredible scale? Welcome to the fascinating world of industrial chapati production, where centuries-old tradition meets cutting-edge automation, and where the humble flatbread that has graced Indian plates for generations is now manufactured with precision engineering that would make any tech enthusiast marvel. From kitchen counters to factory floors, the chapati's journey from home kitchens to industrial production lines tells a remarkable story of innovation. For centuries, making chapati was an art passed down through generations, a labor-intensive process requiring skilled hands to knead dough, roll perfect circles, and cook them to fluffy perfection on a hot tawa. But in today's fast-paced world, where demand for this staple has skyrocketed across restaurants, hotels, corporate canteens, temples, and hospitals, manual production simply cannot keep pace. Enter the modern chapati factory, a marvel of food engineering where technology honors tradition while revolutionizing production. These facilities now produce anywhere from 700 to 5,000 chapatis per hour, with some large-scale operations churning out over 100,000 pieces daily. But here's what makes this truly fascinating. Despite the mechanization, manufacturers have mastered the art of maintaining that authentic, home-cooked taste and texture that makes chapati so special. Inside the production line, where magic meets machinery, let me take you through the mesmerizing journey of chapati production step by step. The process begins in a space that looks more like a high-tech laboratory than a traditional kitchen, where hygiene standards rival those of pharmaceutical manufacturing. Stage 1, the foundation, dough preparation. Everything starts with the raw materials. Industrial chapati production uses premium whole wheat flour, water, and occasionally a small amount of vegetable oil and salt, remarkably similar to your home recipe. But here's where it gets interesting. The proportions are calculated with scientific precision. Commercial dough kneading machines, ranging from compact 5-kilogram units to industrial behemoths handling 50 kilograms per batch, mix ingredients with exact consistency. These stainless steel kneading machines operate for 10 to 15 minutes per batch, thoroughly combining flour and water to develop the gluten structure essential for chapati's characteristic texture. The machines replicate the traditional knuckle kneading technique but with unwavering consistency. Every batch identical to the last. Some advanced systems can process up to 500 to 1,000 kilograms of dough per hour, feeding multiple production lines simultaneously. Once kneaded, the dough undergoes a critical resting period of 20 to 30 minutes, allowing the gluten to relax and the dough to become softer and more pliable, just like traditional preparation methods. This aging process is meticulously timed because it directly impacts the final chapati's softness and puffing ability. Stage 2, the precision game, dough ball creation. Now comes a process that showcases industrial efficiency at its finest. Automated dough ball cutting machines slice the rested dough into perfectly uniform portions at breathtaking speeds, up to 3,000 dough balls per hour. These machines ensure each ball weighs exactly the same, typically between 30 to 60 grams depending on the desired chapati size. Why does this uniformity matter? Because consistent dough weight means consistent chapati size, thickness, and cooking time, critical factors for quality control in mass production. The dough balls then move to the next stage via conveyor systems, maintaining hygiene by minimizing human contact. Stage 3, the rolling revolution. Here's where technology truly shines. Automatic rolling and pressing machines transform spherical dough balls into perfectly flat, circular discs with precision that would challenge even the most skilled home cook. Modern AI-driven rolling machines use microprocessor-controlled systems to adjust pressing time, rotation, and force, ensuring every chapati emerges with uniform thickness, adjustable from 1 to 5 millimeters in diameter. The machines can produce chapatis ranging from 4 to 10 inches in diameter, catering to different market preferences. What's remarkable is how these machines achieve that perfectly round shape, a feat that requires years of practice when rolling by hand. The automated pressing plates apply even pressure from all directions, creating geometrically perfect circles every single time. Stage 4, the baking ballet conveyor cooking systems. This is where the production line becomes truly hypnotic to watch. The flattened chapatis move on to a multi-layered conveyor belt system, typically 3 to 4 layers, that transports them through different heating zones. This isn't just a simple heating process, it's carefully engineered thermal treatment. The chapatis first encounter preheating zones where they begin to cook gently, then move through high heat sections with multiple gas burners, usually 5 or more positioned strategically along the conveyor. These burners, consuming about 2 to 3 kilograms of LPG per hour, create temperatures that mimic traditional tawa cooking. The 3-layer technology ensures even heat distribution from both top and bottom, critical for achieving that characteristic puffing and golden brown spots. Here's what makes this system brilliant. The conveyor speed is calibrated precisely so chapatis spend exactly the right amount of time in each heating zone. Too fast and they're undercooked. Too slow and they become hard and brittle. The entire baking process for one chapati takes approximately 45 to 60 seconds as it travels through the layered conveyor system. And yes, they puff. Advanced machines achieve nearly 100% puffing rates, that satisfying balloon effect that indicates a perfectly cooked chapati. Quality control, the guardians of consistency. Modern chapati factories implement multi-stage quality control systems that would impress any manufacturing engineer. It begins with raw material inspection. Flour is tested for protein content, damaged starch levels, and moisture. Only materials meeting strict specifications enter production. During production, quality controllers monitor dough consistency, chapati thickness, diameter, color, puffing rates, and texture. Some advanced facilities employ X-ray inspection machines that detect foreign objects as small as 0.4 millimeters, detecting metals, bones, glass, or other contaminants in real time. When something is detected, the system triggers illuminating and buzzer warnings, ensuring immediate removal of affected products. Sensory evaluation happens regularly. Trained tasters assess texture, flavor, aroma, and mouthfeel. This human element remains irreplaceable even in highly automated facilities. The chapatis must not just meet technical specifications, they must taste authentic, delivering that comforting, home-cooked experience consumers expect. Temperature monitoring throughout the baking process ensures consistency. Too low, and chapatis remain pale and undercooked. Too high, and they develop excessive browning or hardness. Advanced systems use infrared thermometers to maintain precise thermal control. Innovation and technology, the future is here. The chapati manufacturing industry continues evolving with remarkable innovations. AI-driven rolling machines now use smart microprocessors to achieve perfect roundness through intelligent adjustment of disc rotation and pressing mechanisms. These systems can adapt to different dough textures, automatically modifying pressing force and duration. Some manufacturers are exploring ingredient innovations to enhance nutritional value. Research has successfully incorporated rice bran and wheat germ into chapati formulations, creating products with significantly higher dietary fiber and protein content, up to 20.2% total dietary fiber and 22.7% protein compared to traditional chapatis. These functional foods address growing consumer demand for healthier options. Packaging technology has also advanced significantly. Modern facilities use laminated pouches with multiple layers, typically polyester and LDPE, providing excellent barrier properties against moisture and oxygen. These pouches extend shelf life dramatically, with some products achieving 30 to 60 days of freshness when properly packaged. Semi-cooked and ready-to-eat chapati segments are growing rapidly, offering ultimate convenience while maintaining quality. Environmental considerations are driving innovation too. Manufacturers increasingly use recyclable and biodegradable packaging materials, reducing environmental impact. Energy-efficient machine designs minimize power consumption while maintaining performance. The cultural connection, more than just bread. Despite all this mechanization, the chapati retains its profound cultural significance. It's worth remembering that chapati has been central to Indian cuisine for centuries, mentioned in ancient texts and refined during the Mughal Empire. In Indian culture, chapati symbolizes hospitality and nourishment, bringing families together around dining tables. The chapati even played surprising roles in Indian history. During the chapati movement of 1857, these flatbreads were mysteriously distributed across North Indian villages faster than British mail systems, possibly serving as coded messages preceding the First War of Independence. During the Vaikom Satyagraha of 1924 to 1925, Punjabi volunteers established community kitchens serving over 30,000 free chapati meals to protesters, introducing this flatbread to Kerala. Modern chapati factories honor this cultural heritage while making this beloved food accessible to more people than ever before. The machines don't replace tradition, they scale it, ensuring that whether you're eating in a hospital cafeteria, temple langar, corporate mess, or restaurant, you receive a chapati that respects centuries of culinary tradition. Conclusion: the perfect marriage of tradition and technology. As we've journeyed through the modern chapati factory, we've witnessed something remarkable: how technology can enhance tradition without diminishing it. These facilities produce millions of chapatis daily, feeding diverse populations from army canteens to ashrams, from hospitals to hotels, from schools to corporate campuses. The modern chapati factory represents more than industrial efficiency. It's a testament to human ingenuity, taking a simple food item that has sustained millions for centuries and reimagining its production for contemporary needs. The machines are marvels of engineering, but they're designed with one goal: replicating that perfect, soft, slightly crispy, utterly satisfying chapati that reminds you of home. Next time you bite into a chapati at a restaurant or receive one at a large gathering, take a moment to appreciate the incredible journey it undertook. From precisely measured ingredients mixed in stainless steel kneaders through AI-controlled rolling machines across multi-layered conveyor ovens, all monitored by rigorous quality control systems, to arrive on your plate looking and tasting remarkably like the ones your grandmother made by hand? That's the true magic of modern chapati production. Technology in service of tradition, innovation honoring heritage, and machines preserving the soul of handmade food at unprecedented scale. The humble chapati has entered the industrial age, and it's never been more accessible, consistent, or delicious.